Everybody, welcome to the April edition of our Automationeers Assemble gathering. So to improve audio quality, please remain muted unless you intend to speak. And thank you to those of you who are here for being on time. Please note this gathering is being recorded and live streamed, and the video will be available to watch later. So I'm Dave Hunt, Engineering Manager for the Firefox Performance Testing team. I started these gatherings as a way to keep up with the latest projects and practices. The current format is a monthly gathering with a guest to talk about a project they're working on or a passion of theirs. Please join the Automationeers channel on Matrix, as this may be used for sharing resources and can be used for discussion, and I'll be monitoring there for any questions you may have. So I try to schedule these meetings every month. The times and dates do vary depending on the guest's availability. We do have some plans for the upcoming gatherings, but I'm always looking for more. So if you're interested in being a guest, or you have a suggestion for somebody that you'd like me to reach out to, or a topic that you're interested in, please do feel free to get in touch. So if you've just joined us, I'd like to remind you that please remain muted unless you intend to speak. And note once more, this event is being recorded and live streamed. So our guest today is Patrick Meenan. Patrick works on the in-app browser at Facebook and is the creator of the popular free and open source performance testing tool known as WebPageTest. Patrick can be found on Twitter as Pat Meenan and encourages you to ask questions as we go to lead the content. He also has an awesome home office to make anybody envious, as you'll see. So with that, over to you, Patrick.
Hey, everyone. Yeah, like Dave mentioned, feel free to interrupt as we're going along. I like to have this as interactive as possible and guide the discussions in areas you're interested in, because it could go anywhere from how to use WebPageTest, how to investigate front end, and sort of how the infrastructure is built, how it talks to browsers, what works well, what doesn't, and sort of any issues that I've had over the last, 12 years now, I think, in running it and working on browsers with it. Sorry, going into sharing. Okay, so for those that aren't familiar with it, this is WebPageTest. It's god-awful ugly, but it's very functional, hopefully. WebPageTest.org. You go there, you put in a URL for a site you want to test. You pick a location. Dulles is my house. You see around you, also the basement where I have all of the mobile devices. And then there's locations around the world provided by partners. Basically, in exchange, they get a logo down here and they provide a VM or a server in a location somewhere globally to run tests from. If you can, Dulles tends to have the most capacity and also be the most managed. The EC2 locations spread around wherever there are EC2 locations in the world tend to provide consistent performance if you're looking for sort of a global view of a site and how does it look from various different regions. Beyond those, you start to get into whatever equipment the partner decided to provide, which may or may not be consistent from one location to another. So as long as you're consistently testing from the same devices from the same locations, you'll get consistent results. But if you compare some random test from Amsterdam, for example, versus some random test from Australia, the machines running those tests may be very different. And so that's something you have to be careful of when you're picking locations, at least. Most of the locations are VMs, with the exception of the physical devices in Dulles, the mobile phones, and there's some Windows devices, ThinkPad, and Aspires that have real GPUs. Otherwise, most of the VMs don't have real GPUs attached to them. It's also something to be wary of when running tests. And if you're feeling particularly sadistic, there's some Raspberry Pis running Chromium as well, because it could be done. I tend to use Chrome for most of my testing. We'll explore sort of both of them. All of the Chromium-based browsers basically behave the same as far as communications and support, and they tend to have the most support, partially because I used to be on the Chrome team, but the remote DevTools protocol and the tracing tends to provide a lot more insight into what the browser's doing, and is usually my favorite when debugging something at the first step, at least. Usually when you first get here, some defaults are picked. I highly recommend always opening up the advanced settings and poking around in here. The main thing to look at in there is going to be the connection speed. One of WebPageTest's superpowers, if you would, beyond sort of real device testing and global footprint, is the connection emulation. And it is emulated, but it's done at a packet level with NetM or IPFW, depending on the platform and the sort of configuration that's set up. But that'll give you realistic traffic shaping for what it looks like on a real network. Generally, you'll pick one of the predefined profiles. These were sort of picked over time. You kind of have to point at a dartboard and throw a dart and go, this looks somewhere in the space of what a cable connection usually looks like, just because the speeds vary so much. But this was also set up something like 10 years ago. So cable connections have got quite a bit faster, for example, and mobile connections have gotten quite a bit faster. And so you can also go in and specify up, down, bandwidth, latency, and whatever packet loss you want to introduce. I generally recommend staying away from packet loss when doing synthetic testing, unless you're actually testing the protocols themselves, mostly because it introduces variability. And so if you lose a packet somewhere during a connection setup, for example, that could cause a 3-second delay. Whereas if you lose a packet somewhere during like an image getting delivered or something, it'll be completely unnoticeable in the test. And so those can be some very big swings by random packet loss introduction, and probably something you want to steer away from. You're getting sort of an advanced view. I'm logged in with my admin account, but while I was part of the Chrome team, you could actually upload a custom build of Chrome and run WebPageTest tests using your custom build that you had built locally, and do a broad suite of tests and compare current stable versus your build to see what your results looked like, for example. Number of tests, I usually highly recommend at least 3. If you're only doing one sample, you can easily catch an outlier, and sort of 3 will let you, if there is a bunch of variability across your results, it'll give you at least an idea of which ones tend to be the more consistent. And outliers aren't necessarily a bad thing to measure. They're worth being aware of. Particularly, one thing that you'll see fairly frequently is the first hit to a page may be a lot slower than repeat hits, even though they're all uncached first view, because the backend server caches are cold. And so the first time you hit and visit a page, for example, it'll be warming up the database query and everything else. And all of a sudden on the subsequent requests, it'll be in cache. Which one of those is representative of the real user visiting? It could be either one, right? So you want to be careful and be aware of that. I will say I did go back and watch Annie's talk from last year with cluster telemetry and Chrome's setup. And one of the big differences between WebPageTest and what Chrome does for regression measurement, for example, is that WebPageTest focuses on realism and accuracy more so than repeatability. And so it tries to match the real world as much as possible, even though that may introduce some variability in your results. So it's almost always live site testing, for example, instead of replay. Just because it's really hard to replicate the behavior of reaching out to multiple CDNs and multiple third parties and all of everyone's different protocol implementations for TCP and HTTP2 and everything else. Repeat view versus first view. So what WebPageTest does, when you do 3 runs, for example, and first view only, it will start each browser every time with a completely nuked profile. No cache, no cookies, no settings, nothing. Wipes the entire profile directory, launches the browser, loads the page, shuts it down, and nukes it again before it does the next run. Each machine only runs one browser at a time, so there's no CPU contention going on. It does hurt scalability somewhat, but it gives you somewhat more accurate results. When you do first view and repeat view, the repeat view is still a new browser session. So it will close the browser, kill all of the memory caches, but it won't wipe the profile. And then it'll immediately open the browser and run the same test again with whatever's populated in the cache. Video, I highly recommend always keeping on. I know there's a little bit of overhead. I don't think it's as bad as the 10% Annie was seeing. It's on the handful of percent on desktop and maybe a few percent as well on mobile. But one of the main things that WebPageTests provides is a video capture of the page loading from outside of the browser. So at a desktop level, using iOS or Android's system level screen recording or desktop recording FFmpeg, I'm pretty sure is what it uses right now, to see what's actually happening at the desktop level rather than what the browser thinks is happening as far as the screen is concerned. And we use that a fair bit when we're calibrating like Chrome's first contentful paint metrics, for example, or first paint metrics. We would compare the measurements from within Chrome to what we get in video and see, okay, what we reported is that what's actually showing up on the screen. And it's probably 6 years or so ago at this point, but almost everyone's first paint implementation was very broken. I think virtually every browser, Firefox, Chrome, and IE included, would all, on 50, 60% of the pages, would be reporting a blank white page as the first paint, which is probably technically accurate. It's when the page got committed and there was nothing to display, but it painted a blank white page, which is not terribly useful for the actual user. And so that was one of the evolutions we started with before we sort of flew into the first contentful paint and some of the richer paint metrics. Really quick, any questions? I know I'm kind of rifling.
Yeah, I had one. I typed it in the chat. You have the option for effectively a fresh install new profile and a fresh install a new profile and then reload within that after restarting the browser. The one thing we found is that doesn't match user how users use browsers typically. They don't typically use it after a fresh install or freshly creating a profile. The one thing we use are condition profiles where you've started a browser, let it do all of its first run stuff, loaded a page, just make sure all the databases are initialized, shut it down, cleared the cache, clear cache, shut it down, take that as a condition profile and use that for future runs so that you don't have all this first run stuff fighting with your page load.
Cool. I will say it's not completely clean or first run. Well, it is still first run. It launches the browser. It actually navigates to a locally hosted blank page. And by blank, it still has a little bit of script and a little bit of HTML while it's still blank white to start up the engines. And it waits for the CPU to go idle to let a lot of that first start stuff finish running. Yeah. It doesn't like completely let everything shut down and restart, but it's somewhere in between.
Yeah, that gets rid of, bypasses some of it, but not all the first time profile stuff, because there's a bunch of other things that will happen in databases that haven't been really touched and so forth.
Alrighty. Yeah, I mean, it is also possible in a private install. I don't do it on any of the public instances. You can actually have a profile template that gets copied over. And that's
what we do. We use a template. We make a condition profile, and then we use that template for runs.
Yep. Yeah, for maintenance reasons, at least for the public instance, it's easier for me not to have to do that every time a new browser release comes out, for example.
Yeah, we have it all automated to do that. So.
Cool. Alrighty. On the advanced tab, there's not a lot that you probably want to mess with here. This is sort of a lot of old stuff with certificate caches and stuff. The main things in here that are interesting are the packet traces, the TCP dumps. It will capture the packet capture as well as the SSL key logs and make them both available with the test results. And the response bodies, if you want, for any text resources, if you want the raw HTML, CSS, and JS that was served along with the page. And a bunch of user agent strings. You can modify custom request headers. You can inject some JavaScript to run as soon as the page starts loading. As soon as there's actually a DOM on the page, it will inject the JavaScript while the page is running in case you want to interfere with something that the page is doing as part of your test. And you can also force override it. Usually WebPageTest looks for there to be no outstanding document navigations at the top level. So the main frame has navigated, is complete, onload has fired, and no new navigations at the top level in case of like a JavaScript redirect or something like that. There's no pending top level frame navigations, and there's been no network activity for 2 seconds is usually when it considers the end of a test. There's sort of no universal works for every single page app and video app that you want to test. So you can also force it to say, you know what, run the test for at least 30 seconds, no matter what else is going on, and capture all of the data. There are a bunch of Chrome specific flags and things that you can flip in the Chromium tab. You can run a Lighthouse report. It does that separately from the web page test runs, mostly because we configure and measure different things, and we can't do both at the same time. Mobile emulation, if you want to test from a location other than Dulles, where I actually have physical mobile devices, but you still want to test a mobile page, you can use Chrome's mobile device emulation, which is pretty good. It's not perfect. You're still not actually running on a mobile device with a mobile GPU and everything else. But it does have the viewport, the scaling, it does do some CPU scaling, and the user agent string is pretty much all else it changes. But then you can run that from anywhere in the world. DevTools timeline is usually enabled by default. V8 runtime call stats adds a little bit of overhead to the trace collection, so it's disabled by default, but that'll give you a lot more information about, that's a sampled profiler basically for V8 and what it's doing in every function call. And you can capture a full Chrome trace. If you go to About Tracing in Chrome, there's all sorts of different categories you can turn on. I generally advise people, unless they're actually a Chrome engineer working on something, to probably stay far away from the Chrome tracing. DevTools is a whole lot easier to understand than the Chrome traces are. You can capture a raw net log. That's Chrome's internal view from the networking stack of what's going on. It's generally much more accurate, especially at a protocol level, than what you get from DevTools. For example, WebPageTest waterfalls all actually use the netlog data rather than the DevTools reported data, because it provides much more accurate information. And you can force Chrome into data reduction flywheel. I'm not sure exactly what they're calling it these days, but when you turn on reduced data mode in Chrome and go through the data reduction proxy, that's what this will do. It does all of the image rewriting and things like that. And then you can also specify custom command line options to sort of turn other features on and off, blink features and things like that. Auth, probably not worth getting into, but if you have a site that's behind basic authentication, you put in the username and password, it basically just adds the challenge headers to the requests that are pre-hashed, and it'll get you past the basic auth. Script, there's a link out to the documentation if you want to follow it, but it basically lets you do some interaction with pages and do multi-step navigations and things like that. So you can start with a landing page, navigate through a whole checkout flow, and measure each step of the process. It's not like the greatest scripting language in the world. It's tab delimited and 1 command per line. It has some basic commands for clicking on buttons and things like that, but I generally steer people towards the exec command, which executes arbitrary JavaScript on the page. It's a whole lot easier to debug your JavaScript locally in DevTools and then just put it into a script. And if you can get it interacting with the page that you want it to, you can basically just execute JavaScript as each step of your script in your checkout flow. If you're just doing straight multi-page navigations, that's really easy to do without JavaScript. There are a bunch of script commands that have nothing to do with the page itself, and some of the more advanced capabilities for WebPageTest are actually exposed as script commands. You can modify headers, you can modify DNS records. So one of my favorites is override host. So you can point, like you can say www.cnn.com is actually hosted from mydomain.cloudflare.com, for example. And one of the main things I use that for, so a lot of it used to be when there were front-end optimization software companies, they would use it to show how fast your site would be if you were on theirs, for example. Without actually having to move your site over, you could test your site going through theirs. With Cloudflare, in the last year or so when they launched Workers, one of the cool things that you can do is you can proxy effectively arbitrary third-party sites through your own edge workers and rewrite their pages and do random things to it. So if you are working with clients, for example, you can pitch to them and say, hey, this is what your page would behave like or look like if I rewrote XYZ, or if I got rid of your fonts or added preload headers and things like that. And an override host command pointing it to your domain, you can do a side-by-side video and show them the waterfalls and the video experience, for example, of how much faster it would be or what it would look like. You can block individual requests either by substring. That tends to have a little bit of overhead, but like if you put in .js, you can block anything that has a .js in the URL string. What tends to be a little less overhead and more universally supported is you can block domains and just put in a list of FQDNs to block. And it just adds host entries, pointing those to local hosts, so it's a fast fail. And I'll show examples of what all of these look like in a minute. SPOF is sort of a flavor of blocking, but instead of pointing to local host, it points those host names to blackhole.webpagetest.org, which is an IP that drops all packets. So it's what would happen if this third party went unreachable, for example, or was starting to have problems. And instead of fast failing, it'll time out and it'll test what the browser behavior is when it times out. And it's usually good for finding third parties that you've injected blocking scripts or external CSS in your head that will block all of your content, for example. And let me just pull up some quick examples. So this is when you run individual tests. And down here, if you're planning on doing a visual comparison or comparing a bunch of tests to each other, I highly recommend labeling each one. It makes them a whole lot easier to find later. You can run a whole bunch of individual tests, and then you go into your test history, and it should show you, if you log in, it will follow you across browsers. Otherwise, it depends on cookies, and it'll only be on your browser, but it'll show you the tests that you've run for whatever period of time and by label, and you can pick which ones you want to look at. So I'm not sure which ones of these, and then hit compare, and you can compare an arbitrary number of tests against each other, and it'll pull up the film strip of the tests, for example. This one just happened to be particularly painful in Firefox versus Chrome, and a lot of it comes down to the scheduling decisions made for Chrome holds back on loading non-head resources until after it's gotten past the parser in the head resources, and to try and prioritize first paint, for example. They both end. Firefox actually ends a little bit sooner, but just in exchange for getting more content on the page sooner. And it's trade-offs both make. Down below, if you're looking in just a single test view. So this is what the main test result looks like. you'll get a whole bunch of times and bytes and things like that up at the top of the page. Wow, 500 requests. And then there will be a waterfall. Usually my rule of thumb is if the waterfall doesn't fit on the viewport of the desktop browser, you've got way too many requests. And if you click on the thumbnail of the waterfall, it'll take you to a deeper view where you can see all of the requests that are made to load the page. You've got, if you click on each one of those, it'll give you a whole bunch of details, what HTTP, what protocol it was used, if it's HTTP2, which stream it was, prioritization and things like that. And if you saved, I don't think I actually saved the bodies. If you save the response bodies, you can get to the bodies from here. And right at the beginning of the waterfall, each request item, there's the thinner bar is the connection setup. And so you've got the sort of grayish blue part at the beginning is DNS, and then there's orange is socket connect, and then purple is TLS negotiation. And then for each request, you've got the lighter shade is when it's waiting for the server to serve content. And then the darker bands are when content is coming in. And so WebPageTest Waterfall shows the contents as they chunk in rather than a solid bar for how downloads the entire download. And so you can see how requests start to interleave when they're across connections, for example, or even when they're on a single HTTP2 connection. For example, these two CNN requests, you can see the headers came back really early, which is kind of a typical HTTP2 behavior. And then they prioritized and sent them in order and sent the bodies for the requests later. But the fonts, which were on a different CDN, were coming down at the same time, and you can see the gaps that it introduces into the JS download, for example. And as you span more and more connections, you get more interleaving. The pink bars that are sort of scattered throughout the waterfall is JavaScript execution. So if you see way down at the bottom of the waterfall, and this was a very long waterfall, there will be a main thread graph that shows what the main thread's doing. JavaScript execution is orange, layout is purple. Actually, I think layout might be blue, and image decode is purple. There's also a bandwidth and a CPU utilization graph. And generally, I like to see the bandwidth maximized for as much time as possible. Otherwise, when you get gaps like this, you know you're not utilizing the connection as much as you could. But when you see spikes and like in here where you have large chunks below, red is the page is not interactive. It's blocking. If the user tried to do anything, it wouldn't be responsive for like a second here, for example. And if you scroll up, you can sort of correlate those. Oh, that's the connection view. 2 waterfalls above. You can correlate those with the actual JS execution and which file was executing JS at the time. And so here we can see it's the main bundle. For example, here it was evaled, and here it's just doing a whole bunch of execution either on DOM content loaded or other timer-based events. And if you want to dig into more on what's actually going on for the JavaScript execution in the main results, if you click view on the timeline, there's an embedded Chrome DevTools timeline where you can use the regular DevTools and do a deep dive into the raw function calls for everything. But in a single page film strip view, which is sort of where I was trying to go when I came to here, as you scroll around up here to look at the film strip, down below there's a red line that follows in the waterfall. So you can see, okay, this is the point where the hero image actually loaded on the page, for example. And you can go down in the waterfall and see all of the stuff that was going on before it and figure out how much of that was actually critical to loading that hero image. And in this case, my guess would be most of it is not, but just a lot of stuff contending. But you sort of get the one waterfall view. When you're doing a comparison, like here we had the Chrome versus Firefox, you get the same moving red line, but you have multiple waterfalls overlaid on top of each other, and you can sort of fade in between them and see. It's interesting that Chrome actually, it looks like CNN's doing a whole lot of preloads, which I'm not sure if they're supported or not in Firefox, but in this case, they're actually not getting triggered at least. And then you can see the massive sort of stair step that they've got going on here before most of the content starts loading. Whereas in the Chrome case, you can see they shoved a whole lot of content down sooner, and you get more of a horizontal squishing, if you would, of the requests, which is probably why it painted so much sooner. And here we go. So in the case of The Verge, I added CNN wasn't as exciting, but I ran 3 tests where I blocked. I don't show what got blocked. Oh, here. cdn.concert.io, which is one of their ad providers, which they have as a blocking script in the head of The Verge, for example. And so if we block the concert.io domain, and if we spoff it, or send it to a black hole, we can see what the behavior difference is versus the production site. And so here we can see clearly, so The Verge has kind of a user annoying behavior where it loads the page, then injects a massive banner at the top and slides everything down. And so clearly that's what Concert does for them, because in the case of the blocked, you get the consistent behavior. It doesn't black out, it doesn't slide the content, which in this case, it was painfully from 6 seconds all the way to 9 seconds doing that slide down. But in the case of the SPOF, where we black holed the third-party provider, the page stayed blank for 32 seconds. And that's a Windows-specific timeout. Linux and Mac OS is 60 seconds on the TCP Connect timeout, and so it would be blank for much longer. And this works really well for showing people that even though their backends are responsive, if the third party goes down, it's not something their monitoring tools might catch, but it's still probably an outage as far as their users are concerned, because most users aren't going to sit around staring at a blank page for 60 seconds waiting for it to load. And so none of their monitoring tools will catch it, but it'll still be down. And this demonstrates to them very well on what it looks like. The film strip view, also below it, there's a create video button, which will go ahead and render a side-by-side video. We'll give it just a second to finish. And you can see, I don't know how this will come across Zoom, but you can see sort of what the user experience would be as the pages are loading. This is sort of the view, which is sort of the money shot for WebPageTest for a lot of the front-end optimization companies on why they used to use it for showing off how much faster things would get, because they could visually show the executives that signed the checks what the experience was when it was faster versus when it's slower. And see, we're finally loading the content now. Yeah. And so that gets across the SPOF, because you can tell someone 30 seconds or 60 seconds in a film strip, but until you actually experience it, you don't get a real sense for what it feels like. Okay, so really quick pause for more questions, just because I dumped a whole lot on you all at once before I go on to some of the other things. No, I guess we're good. All right, so in the custom section, there's actually 2 different things that are kind of buried in here, mostly because I didn't want to add more tabs. Custom metrics. After a test is run, it will run arbitrary JavaScript that you provide in the DOM and extract whatever information out of the page it is that you want. And so we've added a whole bunch of things to the HTTP archive, for example, for collecting like average DOM depth or number of DOM elements and things like that. without having to add it to WebPageTest proper. It's just sort of custom metrics that we wanted to collect as JavaScript. You can also use it for validation. If, like when I was at AOL, one of the things we used to use to validate is that the page that came back actually had the copyright AOL text on it to make sure we actually got the page we were trying to load and not some error page or redirect page or something like that. More recently, there's also been support for like let me zoom in a little bit. There's been support for adding string substitution. So you can either do $WPT underscore requests or bodies. And what that does is it provides it, when the script goes through the agent will rewrite those strings and insert a JavaScript array, or a dictionary actually, of all of the it's an array of all of the requests that were used to load the page, as well as all of the headers, the security certificate information, bytes in, bytes out, and in the case of bodies, also the response bodies for the request. So your custom metrics can also iterate over the request data from within the DOM of the page. And so one of the things like Tim Cadleck's done, and he just tweeted about it like half an hour ago, was he wrote a custom script that iterates through the DOM and counts the number of non-async scripts in the DOM. And then it also looks at the response HTML for the number of non-async scripts that were sent directly by the HTML. So you could see how many were injected by script dynamically versus how many came in the HTML. You can start doing some really cool things with it there. On the hero element, in the case of the web page test results, let me go back to the first. If you click on the screenshot, there are, that one's less useful. Let me see if the CNN one has better hero element timing. So one of the things that SpeedCurve, SpeedCurve's performance monitoring runs on top of WebPageTest agents. And one of the things they added was hero element timing, which was after the test completes, it will look for the largest image close to the viewport and like the first H1 element. And it'll default those as your hero elements on the page. It'll get the rectangle for where those elements are defined, and then it'll iterate over the video and see, okay, at what point were those elements populated and at their final state, basically. So when did that rectangle match the end state? And so if you click on the screenshot, it'll show you a rectangle around the hero element, as well as when it was recorded or when it showed up in the video. And you can use this to validate your hero timings, but in the custom selectors, you can actually specify custom selectors to measure different elements than it would have picked by default. There's also, if you click over to the documentation, there's like a hero timing spec. I can't remember the exact name of it. But if you tag your DOM elements with the hero timing spec, it will pull those out by default instead. But if you don't tag it and you don't want to use the defaults that it picks, you can provide custom selectors to pick different elements as well. Bulk testing is hidden by default. I'm logged in as an admin, but if you log in with basically any Google account, it really only has Google OAuth integration for now. And you add a bulk equals 1 query param. Anyone can add the bulk testing tab, and you paste in or upload a file of a whole bunch of URLs. You set the rest of your test parameters the way you want them to run, and you hit run, and it will run them all and give you links to each one of the test results, as well as a downloadable CSV of all of the results in aggregate, as well as the raw request data for all of the results. That's it mostly for the UI. There is an API. So everything that you can do through the UI, as far as selecting tests, running tests, getting results, can also be done through an API. Originally, it was XML. There's also a JSON API, which is just a whole lot easier to use. Fundamentally, they all do the same thing. The UI uses the API to do its testing. So anything that you can do the UI, you can automate and do for bulk testing, for example. And so with Chrome, for example, one of the things we do is I'd have a Python script basically that just took a whole bunch of URLs, submitted the same URL with multiple configurations, either a dev build and a production build, or Chrome versus Firefox, for example, or Chrome versus UC Mini with data saver mode. And it would run, it would submit each URL to both browsers to try and get the tests run as close in time as possible for each URL, since we are testing live sites and live sites tend to change content over time. We tried to alternate when we're running instead of running all for one browser and then running all for the next browser. But then it would just collect the results for each one, spit out a CSV for the metrics that we were currently concerned about looking at, and let us look for which ones were outliers, which ones improved, how many regressed, for example. In the UI, you can click on View JSON Result for a given test, and this is the raw data that you would get back if you asked for it using the API. And it gives you the URL as well, but there's also links to the documentation for the API. And the API provides a whole lot more detail than you can get at through the UI usually. Sorry, I've got that's my mistake. I downloaded the JSON for CNN with its 600 requests because I also have a JSON browser extension that makes it easy to collapse and expand. I'll let that run for a little while and we'll come back to it. As far as, I think those, so it's all open source. I run a WebPageTest instance for the public to use. There's a whole bunch, I'm not sure if Mozilla is still running their own internal instance, but a whole bunch of companies run their own internal instances for doing either huge volumes of testing or for testing within their firewall, things like that. Like one of the things that I used to do a fair amount when we were working with ad partners, for example, is I'd have an instance that was running on GCE, and I'd have one agent connected to the WebPageTest server by default. And if it's doing nothing, it uses 0 CPU, and I would have it auto scale up to, I think the most I ever got was 5,000 agents based on CPU utilization. So if the average agent CPU utilization went over 20%, it would scale and add more agents. And so I could do a bulk test, submit a few million URLs to it, it would scale up, do a whole bunch of tests, and then automatically scale back down. There are links at the top of the WebPageTest to documentation, which will take you to a variety. It used to be a Google Pages thing. Now it's trying to migrate most of the documentation to GitHub. There are install scripts for EC2, Google Cloud, and for just plain Ubuntu to automatically install everything you need for the agent, all the dependencies, and get everything configured. Same thing for the server. So it makes it fairly easy, at least on Linux, to spin up a new agent in a private instance configuration. And one of the other cool things that was built on top of WebPageTest, if you haven't been paying too much attention to it, is the HTTP-2 prioritization. So one of the things that we test with WebPageTest is there's a test page that you can give it an arbitrary image that's hosted on a third-party domain. Usually, if you want to test your CDN provider, for example, you get an image roughly around 100K that's served from your CDN. And you run it through this test page on WebPageTest, and you look at what the waterfall looks like to see if the high priority resources that should be loading soon, but that are injected at the end of the page, actually do load soon. And you can see sort of a lot of cases where it doesn't load quickly and gets delayed, and it sort of for detecting when prioritization is busted on the server side. You can also do the same thing when you're looking at sort of client-side prioritizations, what the order of the requests look like. And as far as device porn goes, this is the mobile lab. So this is what my basement looks like with all of the mobile phones. Each one of the mobile phones is basically a 3D printed mobile phone holder with a Raspberry Pi strapped to the back of it and a phone on the front end of it. And it's all powered over PoE. So I have a switch that I can automatically reboot devices if they hard freeze, for example. Although the Raspberry Pis have a really nice hardware watchdog that the agent is integrated into. So the agents will write out an alive file that the watchdog watches out for. And if that ever freezes, theoretically, the Raspberry Pi hardware watchdog will reboot it before I even notice. And so there's just banks of phones all plugged into a PoE switch, running agents on them. Most of them are 3 or 4 years old at this point, so batteries are starting to swell. It's a fun thing about running mobile device labs. Like Annie mentioned, I do very similar things that the Chrome team does. So at least with WebPageTest, each test is fairly short in time. It's not more than 30 seconds to a minute at most for most tests. And so before polling the server for work, the agents check the phone and make sure it has connectivity and that the battery temperature is low enough. And so that way it prevents any of the phones from getting too hot and really swelling the batteries. And so if the battery temperature is over the threshold, like 33, 34 degrees Celsius, I think, it'll just sit there and wait and won't pull the server for work until the battery temperature drops below the threshold. And then these are the Raspberry Pis that are sitting on top of the device lab. I think those were the highlights. If there was anything anyone wanted to ask about any part of it and how it plugs in.
There was a question that came in regarding the Android devices. Did you pick those devices for particular GPU characteristics, or were there other reasons? Can you give any expanded commentary on why these devices, or what devices you'd pick to represent the mobile market?
Sure. So they were cheap, which was my number one requirement. Generally, I like to have rootable devices. It's not a hard requirement, but for Chrome, at least, to override the command line options, you need to be able to root the devices. So my main requirements were inexpensive, rootable, and roughly equivalent in CPU and GPU to what the middle to low end of the market was. I tend not to try because most devs have really high-end phones, and I do have a couple of one-off examples of like Galaxy 7s, and I have one-offs of almost all of the iPhones and iPads, for example. But the bulk of the devices are Moto G4s and Moto G Generation 1 from like when I first set everything up. Those are really slow. Mostly because they work reasonably well as far as a mainline device. They have mostly vanilla Android on them. They're rootable. They're easily bootloader unlocked. It doesn't require like any custom Android builds or anything like that. So like the Google device lab mostly uses Nexus devices with custom builds and things like that. And so WebPageTest doesn't throttle the CPUs or do anything else outside of checking that the battery temperature is right and writing to files and locations that normally aren't accessible if you haven't rooted for like the Chrome command line options. I will say on the Android devices, there's kind of a range of browser support. Chrome's the only, Chrome and iOS Safari are the only browsers that have like full remote dev tools support as far as WebPageTest is concerned on mobile devices, and they get the full waterfall and everything else. WebPageTest does have what it calls a black box mode, where it will run pretty much any browser. It'll launch it. It'll start with a completely clear profile, it'll wait for things to idle out for a while, and then it'll start navigating and load a page, and it will record the TCP dump, the bandwidth, and the video of the page loading. And so the main thing we use that for is visual comparison of the pages for like Chrome mobile versus Android, Opera, or UC Mini, for example, browsers that we don't remotely control directly. We can still at least see how quickly does it load the page, how quickly does the page content get loaded, how many more bytes or less bytes are we delivering versus another browser or something like that.
Another question related to the mobile devices is, are you using Wi-Fi for all of the phones or something else?
So most of the phones are reverse tethered over the USB connection to the Raspberry Pi connected to them, and then the traffic shaping is done on the Raspberry Pi. There are a few phones where I couldn't get the reverse tethering working quite right. I've been meaning to write a modern version of the reverse tethering app. There aren't any really good ones out there right now. For those, it is connected Wi-Fi to a, right off the screen to the right, there's a Airport Express, one of the more reliable Wi-Fi routers I've ever had, which is connected to a BSD box running DummyNet. And so I have each one of the phones that are connected over Wi-Fi set up with a dedicated pipe on the DummyNet server, and the Raspberry Pis will SSH into the DummyNet server, configure the pipe with the traffic shaping parameters that are needed, and then run the test over Wi-Fi locally to the device. That's how my setup is. Technically, WebPageTest doesn't care. It will run, if you want to put devices on a 3G network, for example, it will run tests. It just won't apply any traffic shaping. If you have too many devices talking Wi-Fi too close to each other, it causes problems. And so once I got over more than 15 or 20 devices, you could start to see effects of having that many devices on Wi-Fi and adding jitter to the connections, which is why I've gone to reverse tethering most of them so that they have rock solid connectivity. And then I just do the connection emulation using IPFW or DummyNet. Sorry, IPFW is DummyNet, NetM or DummyNet. Sorry, there's a question about battery temperature is right. By that I mean, I can't remember what dump sys I do, but if the Android phones get too hot, they will throttle the CPU, but batteries will also tend to swell a whole lot more and much sooner if the phones get too hot. And sort of a common monitor for the phone temperature is the temperature sensor on the battery. And so there's a dump stat somewhere in ADB that'll give you what the current battery temperature is. And the agents just, before running any test, it pulls the battery temperature to make sure it's less than, so that the phone is effectively less than 33 or 34 degrees centigrade. I do not measure other temperatures, just the battery temp. There's a question about fans or AC in the room. There is AC, but it's my storage room in my basement. There is a rotating oscillating fan like right in front of the shelf, basically blowing air over all of the phones, which is kind of why I have them oriented sideways, so I get reasonably good airflow going across the phones. The room itself isn't significantly hotter than the rest of the house, which probably helps with the battery temperatures and keeping them down. But the extra fail-safe in there really is just checking the battery temperature before running any tests. RUM SpeedX I clearly don't know how to do all chats.
I was just wondering if you had had any success with RUM Speed Index, because I find it quite attractive because we don't need to do video capture, and just wondering how that worked out.
I know a few people use RUM speed index. I think Mpulse is doing something with the flavor of it. I think they've like enhanced it a little bit. It works pretty well. It correlated really well with the video measured speed index. There are, edge cases where it doesn't work, right? And so it's one of those things where, as a site owner, if it works well for my site, I would definitely deploy it. But doing it at scale, it's one of those, like from Chrome, if I was to measure RUM speed index and use it as a Chrome measurement, it probably has more cases where it fails than it would be useful. iOS versus Android testing. iOS, the bane of my existence. So iOS actually provides a fair amount. I haven't played with, so Safari just released, I don't know, what is it, iOS 13 with remote automation support for WebDriver for Safari, which I haven't done anything with yet. On iOS, I have a WK WebView shell app that my agents talk to that then does most of the video recording and browser driving, which should be accurate. And then the agents talk DevTools to the browser itself. But we're still somewhat limited by what we get through Apple's DevTools protocol implementation, which is, it was mostly stuck in time in what it looked like before Chrome forked. They've made a bunch of changes to it recently, which unfortunately means they broke it recently. And so like right now, with the current iOS releases until iOS 14 comes out, you can't get the timing data for the HTML for a document, for example, for the first request, because of the way they do async notifications and things. So the capabilities of what we get out of Android tend to be a whole lot better than what we can get out of iOS. That said, my iOS devices are a hell of a lot more stable than the Android devices. I mean, for the most part, they'll all run for a year or two without being touched for the most part. But the iOS devices, until very recently, I think they've run 5 years or so for most of them without having any battery swelling. And I've just started to see battery swelling on them, for example.
I had a question that came in ahead of time about your use of the Marionette Python client. It was a question, is it still being used? Mozilla are no longer releasing updates to that, so it's probably would be a good time to stop using it if you are.
Yes, it's been long past a good time to stop using it. It doesn't work on Python 3, for example. And so most of the agent is now Python 2 and 3 capable, and most browsers will work, except for Firefox because of Marionette. There's not a lot of things that the agent does through Marionette. So for Firefox, for example, and Chrome is also very, very fragile because I parse raw netlog data, which is mostly like developer printfs. For Mozilla, for Firefox, I literally parse the raw printfs in the HTTP logs, the Moz logs, for most of the request data. So it tends to be kind of fragile, but that's how I get most of the request data out of Firefox. And so I only use Marionette for, not even for launching the browser, but for setting the prefs and for executing JavaScript for the most part. And so replacing it with WebDriver isn't hard. It's just something I need to do. I just haven't had time to do it yet.
Does anybody else have any questions for Patrick?
Cost of my initial device setup versus ongoing yearly maintenance. So initial is kind of hard because I've sort of been adding phones over time. There were a couple of, my initial, like my servers were $600 servers that I bought off of eBay, sort of old Supermicro 2U or 4-unit stack things that are running the VMs and that kind of thing. So like $1,200, and I have 32 VMs and the web server. When I stood up the bulk of the Moto G4 devices, there were 24 phones in all, I think, at the time, and we bought a fairly expensive, and by fairly expensive I mean it was like $1,200 PoE switch, a 48-port PoE switch. The phones are $100 each, give or take, and the Raspberry Pis, including the SD card and the PoE hat and everything else, are probably another $100. So each phone, roughly ballpark $200 for the Android devices. You couldn't get near an iOS device for that. But I usually, for the iOS devices, I usually look for refurbished devices or things like that, because I don't need a new device with a beautiful screen or anything. It can be scratched up or whatever. It still works fine. So yeah, I mean, the mobile device lab's probably much more expensive than the physical device lab. The ThinkPads, I have a stack of 10 ThinkPads. They were off of eBay, like $300-400 each as well. Also didn't need them new. So I mean, it's not a huge budget. Ongoing costs these days, power, for the most part, it's a rounding error. I don't know. I'm sure my cooling bill went up a little bit. I buy new batteries for the phones every now and then as they swell. Those are usually $20, give or take. So not a whole lot of ongoing costs for running it. All right.
Awesome. Well, I see that we're at time, and so I want to be respectful of your time, Patrick, and our guests, our audience. So I want to say thank you very much. That was awesome. There was a lot of great questions coming in and some commentary also in our Riot channel. So thank you for everybody for attending. Look out for details of the next gathering. Once again, thank you, Patrick, and take care, and see you all again soon.